I'll use this one. There we go. So that was setting the stage for disruption for sure. Thank you. We already used 1 minute on that process. Thanks for having me. It's a huge pleasure to be here. I was researching South Africa from a political economy perspective. I'll go into what that means about 1.5 years ago. So certain of the thought leaders here I've already been in contact with. Briefly about my academic background, something about politics, something about business. We study the relationship between politics and business. Who has the power in that relationship? Is it the capital, the private capital, or is it the public funding? And how do they play a role in driving progressive change? So that was what I studied in South Africa, and finally being here now, seeing hopefully what is applied on the field. So not only how technology can be imported, but most importantly, locally developed and hacked, if you will, to fit local demands. We cannot just import technology from the US. We know this also in Denmark. We have to locally fit it to our needs. At the moment, I'm working on trying to get some of the latest tech to Denmark. In fact, we are way behind in comparison to where South Africa is in the 3D printing field. So disruption, this notion that we tend to throw away everywhere when there's something that is changing and we don't really know what it is, and for some people it hurts. I'll go in to talk a bit about how disruption can be used as a strategy to create and not avoid. A bit what Peter talked about, create the future that you want to see instead of trying to predict it and then avoid disruption. So that's what I'm doing at Dare Disrupt. We're tech advisors. And we work a lot with mind setting. For us, we believe that if this technology, 3D printing being one of them, is supposed to enable things like local entrepreneurship, there's a lot of work to be done in communicating about them and providing what we call a basic level of technological intuition. I'll go a bit into that as well. The future I wanted to see, or rather not see, is this one. In light of technologies like 3D printing, this future for me does not make any sense. It doesn't make any sense that we mass produce in China, get it transported all the way to Denmark in my case. It doesn't make sense to mass produce, store in huge warehouses. It doesn't make sense to have subtractive technologies in light of climate change. Doesn't make sense to have so much waste that is associated with this kind of organization around economic activity. It has created a lot of growth, industrialization for sure. This kind of organization globally has created a lot of growth, but it has been unequally distributed. And that's the other aspect. Technology, the new technologies of the digital realm need to be empowering, and they also need to be green. So this is my own personal agenda and a bit what I'll try to loop into when I talk about 3D printing. Before being a tech advisor at Dare Disrupt, I worked in actually that company with the goal of disrupting them from within. I was working with procuring engines for all the business units in the Maersk Line company. And just for the sake of a bit of perspective here, that's a guy working on these two-stroke Wärtsilä designed engines. And my opinion when I saw this, and I had fallen in love with 3D printing already for some of the reasons I explained earlier, is why does this engine look the same as it's done for the past almost 100 years? When we have a new technology that can do something totally different, how will this engine look? And so as this sort of very annoying external person, I was working with engineers on a daily basis. I tried to drive some innovation and some new way of thinking inside the organization. I started to organize this hackathon. I invited makers in our local community, and I basically told them, hack away the parts that are on board, our engines. And here you'll see somebody has the Ultimaker here, other printers they built themselves. My manager here is looking at the 3D printer. He's very suspicious. He doesn't even want to touch it, in fact. Later he does. Somewhere here it dawns on him that, wait a minute, will we actually need shipping in the future? I didn't place those words in his mouth at all. I tried to make these guys consider this themselves. The part that we ended up, if I'll go back, what we needed to do very soon was actually to educate the entire maritime industry. This was back in 2013. At that point, when I talked about 3D printing, I got the response, 3D what? So the maritime was very far behind. So there was a lot of work within communication, and I, as a political economist that had researched 3D printing for about 4 years before, was considered the expert, just to give you an idea. So this was my idea, what I wanted to do, and what I threw out to the digital space and to the industry.
For this kind of 3D printer, you would typically use the raw materials such as ABS, which is a thermoplastic that here is hard, but it will liquefy once it's in the printing chamber. So it will go through an extrusion nozzle and there become liquid. And when the first layer has been solidified, you'll print a new layer on top of the old one. The idea is that we send a blueprint to the crew on board the tanker vessel. They will push print, and in about hours get the part.
Easy, easy peasy. We'll just put them on board the vessel, we print our parts, everything is fine. Obviously, there's more to that, but let me just show you a bit what happened. This new technology entering a very conservative industry. I was at the bottom of the hierarchy, and I got invited to speak at the World Shipping Forum in China to talk about 3D printing as the expert. We were nominated to an innovation award. At this stage, it was only an idea. Between us, the 3D printer I'm standing in front of is borrowed by a design firm in Copenhagen. So at this stage, I had invited makers for coffee. I was standing in front of a 3D printer that wasn't my own, and I had just made a little communication stunt, and the entire maritime industry sort of shrugged and wanted to move into the space. This was the part I ended up suggesting that we should print together with the makers. It's a plastic fan that breaks really easily, and it's on top of an electric motor. And when you don't have this part outside of Angola, it takes you 6 months to get it through customs. So holding high stocks on board the vessel is, first of all, very expensive. So definitely something you want to circumvent. But the engineers, when I showed them this at the company at Maersk, they loved breaking it. It's very fragile in between the layers. So they broke it every time I showed them a new one. So definitely I had to do some calculation. What was going to be the future of 3D printing? When was it going to be good enough for us? And what I did was to look at the previous, at that time, 5 years, the ones that I had researched and thought I understood. And then I projected the next 5 years. And I did so linearly. But you see, when something is digital, it does not develop linear. It develops exponentially. And that's a huge paradigm shift of all the digital technologies that we're seeing today. And it's not only 3D printing, it's robotics, it's artificial intelligence, it's even blockchain technology, which is a new way of organizing around transaction of value. All of these technologies are morphing and fueling even more growth. And February this year, I had the pleasure to inaugurate the field lab in Port of Rotterdam and moderate that session. The maritime industry, in my point of view, have moved so much further than I could estimate into my analysis. But first, the same month that I was coming up with some kind of investment proposal, this Carbon 3D came out. I don't know if you remember sort of the shock in the 3D printing industry, claiming that they had a technology that was up to 100 times faster than the existing technology. This was a technology that was kept secret by the VC investors, Sequoia, one of the largest VC investors in the valley, and it really shocked the entire industry. At the same month, also an open source metal 3D printing project where an MIT student said, you can make a 3D printer for $1,500. Sure, very rough in the edges, but nonetheless, how could I calculate this into my NPV analysis? There's no way for me to foresee these new ways of thinking that enter 3D printing. And back to what I had the pleasure to inaugurate, I'll show you a bit there. It's not only about plastic, which was my original idea because I thought metal was way too far ahead. Now it's also about metal. So.
Sometimes, the smallest details demand total dedication, great care, and meticulous precision. In a competitive world, time is of the essence, and its scarcity puts pressure on all of us to keep innovating. This requires great commitment and the ability to channel all effort into the task at hand. Without pause, without distraction. Things may break down, yet the world keeps racing ahead. Parts need to be replaced to keep things up and running. It's imperative that everything falls into place at exactly the right time. That's the synergy of teamwork. When craftsmen and experts join forces, they deliver solutions that transform the way we do business. 3D printing in the Port of Rotterdam. Shaping business. Creating opportunities. Make it happen.
It's unfortunately not Morgan Freeman. I was really disappointed. But so 2 years after I came with my linear assumptions in my investment suggestion to the board, this field lab was inaugurated by the Port of Rotterdam. And what basically the CEO of Port of Rotterdam is doing is that he is understanding this exponential space we are in, this paradigm shift of going from the analog linear technologies over to the digital exponential technologies. And so it started with computing, if you want, that we totally underestimated its exponential growth. We'll see the same thing with internet. Bill Gates supposedly said that was just a passing fad. Or mobile technology. We keep underestimating the growth of these technologies. And so if you're an expert, be wary of your assumptions. And the next technologies that build upon computing, mobile technology, and the internet, and that fuel this continuous exponential growth of digitalization is artificial intelligence, robotics, and in fact, 3D printing. I would dare to say that 3D printing is a bit less exponential at the moment than artificial intelligence and robotics, but that is just to the fact that AI has existed since 1956. And at that time, it goes really, really slow. And now, when the computation power is strong enough, when the data is rich enough that fuels these technologies, it's now we're seeing this growth. If anybody has seen this one before, you'll know that it's one of the most boring graphs. It's the most boring graph that I will show you, but it's also one of the most important ones. It's looking at Moore's law, not only applied to the integrated circuit, but applied to the very start of computing. Ray Kurzweil, the founder of Singularity University in California, he's also called the 87% man. So he predicts right the exponential growth of these technologies 87% of the time. It's because he uses this graph to calculate the projection. And if you have an eye for detail, you see we're dealing with a logarithmic scale here. So as I move up the y-axis, I'm actually multiplying and not adding. So if this was perfectly exponential, we'll see a straight line. Because as you can see, it's actually curving upwards. In essence, it will never be as slow and nice as it is at this very moment. From now on, only go faster. As a non-engineer, for me, when I see this, it's mostly, in fact, a religion. It's a belief in the human ingenuity that we keep innovating. And when we can't have more transistors per inch on the integrated circuit, we'll move to the next paradigm of computing. This computer, from the end of the 50s at MIT, at one point, it became powerful enough and cheap enough to be coupled with 3D printing. This is Chuck Hull's first 3D printers back from '86, I believe. So at one point it became affordable enough. And today we have, my phone is 1 million times more powerful, 1 million times cheaper, and 5,000 times smaller. That's a million times 5,000 in price per performance. It's nothing like we've ever seen before. And it's not only the computation power. Could somebody guess what this is? I'm sorry, a hard drive? I'm talking to the right crowd. Somebody said a couch last time I showed this. Hard drive, exactly. This is the perfect crowd. It's a 5 megabyte hard drive. Yeah. A bit later than the computer picture. And so if you have a 16 gigabyte smartphone, you would need 3,200 of these fellas to just fit the same amount of data. And I just upgraded to one of these new ones that had 254 gigabytes. I cannot even fathom. That's 50,800 of these fellas. And we're laughing at that, but our kids are probably laughing at us when we show them this. The floppy disk. They don't even think it's a thing that existed. It's just a save button in Word, right? Somebody must have 3D printed that. Did that ever exist? And now everything is here, and this is where it gets really messy. Here is where everything becomes digital and dematerialized, and they're also more accessible. Music, you don't really consume music, you stream it. It's turned into zeros and ones. Your news, this is probably another age test to show your kids the envelope. And so on and so forth. And now 3D printing is enabling the digitization of the product, of everything physical around us. Internet, mobility, computation power, data, efficiency enables us to now share drawings on Thingiverse, enables us to access a network of 3D printers. If you haven't used 3D hubs before, do so. If you don't own a 3D printer, search into the local 3D printers around you. This is like the Airbnb of 3D printers, what I used. Amazing. And here you share all the information, you get access to low-cost prototyping, and in fact, that must be some enabling aspect of technology. And this is what drives Moore's Law. This is what drives the exponential growth of the digital space, the network effects. And so Port of Rotterdam knows that their initiative is useless unless ports all over the world are doing the same thing, because they want the network effects. Value of one field lab, 0. Value of more, exponential. And so they're sharing their method with them. And for me, this is the most exciting exponential curve ever. How many years it's taking us to connect 3 billion people to the internet? Probably approximately 23 years. And by some new technology, not cables in the ground, maybe Google Loon or a solar powered drone, we'll be able to double that amount in only 4 years. This is a record of how many people are getting connected to the internet as we speak. New minds, new people with new ideas, solutions to problems we didn't even know existed. And that's going to fuel so much innovation, I believe, in 3D printing. And it's also what forces the expert to reconsider their estimations. Forbes looked at the previous forecast of the growth of 3D printing market, marked in yellow, and then the current forecast, so more updated. And this is asking the experts, the BCGs, the McKinseys, the professors of the Ivy Leagues, aggregated, they have to update their forecasts. And when a new player like Maritime enters, in fact, experts have to update their forecast accordingly. So we work with 3 assumptions about the digital space, how to be empowered with this technological intuition I mentioned earlier. First is knowing that when we're moving from an analog to digital space, we're moving from the linear to the exponential space. Digitalization decreases the cost of many activities in the traditional value chain. For me to send a file of a STL file, 3D printable product to you or anybody in this room or anybody with access to the internet doesn't cost me anything. And that creates crossings. New people can afford areas that before, industries that before have been very conservative. Enters the barriers go down. And that's what disruption creates. That's where we see disruption. New minds with new ways of thinking, new rules of the game. With Port of Rotterdam, what we're seeing in terms of the creative crossing is that maritime and 3D printing are in a dialogue, which they've never been before. When I tried initiating that way back, a lot of the experts in the 3D printing industry didn't believe that we could print these massive parts, purely from an economic point of view. It doesn't make sense. Too big, the raw material is too expensive, but when it takes us 6 months to get a part through customs, or when a rig costs us $500,000 in downtime per day, then all of a sudden, the cost-benefit changes. And all of a sudden, the 3D printing guys got interested in our industry. And what we're seeing now from this creative crossing is, in fact, that the Port of Rotterdam are putting new demands to the 3D printing industry, developing large-scale metal 3D printing. One of the gurus of disruption, maybe you know him, Clayton Christensen, Harvard professor, talked about the innovator's dilemma. And we have to go back to the original theory to hack it. And that's what we do at Dare Disrupt. His theory about disruption is that if you're an expert in a field, you provide a product and you're always going to be good at perfecting that product. You're good at incremental innovation. You keep perfecting, perfecting, perfecting. At one point, in fact, maybe you'll be so far above the performance that customer needs that they'll move to an alternative. As you move up here, this scale, chasing higher margins, you open up a space here for disruption. And that's what we see historically, new players betting on a technology that is scruffy, poor quality, maybe more expensive, something that the incumbents don't want to touch. They are so good at what they're already doing well today. So at some point, with the progress of technology, the disruptor will meet this axis of what the performance customers need. And that's when all the customers move to the new technology. And so in an exponential space, the first thing we need to hack in Clayton Christensen's model is the lower curve. It's happening faster, this disruption, because we're betting on exponential technology. Clayton Christensen wrote Innovator's Dilemma back in '97. That was the same year Google came out with a beta version. So imagine all of the new information that people can access, disruptor can access, following '97. And the innovator's dilemma is basically, as an incumbent, you will have to go down and meet the disruptor. You will have to bet on the new technology, although it does look scruffy in the beginning, although the 3D printed part is not fantastically polished. That's what you have to bet on to not be disrupted. And in the Port of Rotterdam case, that's exactly what they're doing. They're starting to look at the concept of good enough. When is it good enough to have a 3D printed part that is rough in the edges? Do we need to start with the most critical parts? Maybe we can start with parts where it's just good enough that it looks like this. And that's what they're doing at the moment. And doing so, they're starting to learn the technology, and they can follow the curve and be prepared when it develops exponentially, both in price and in quality. And that's what I should have done. I should have told the engineer when they broke my fan, I should have told them, isn't it good enough? Isn't it better than not having a fan? Sure, maybe it'll break, but we can print a new one on board the vessel, and it'll be a good enough interim solution until we get the original part. In Nepal, after the earthquake, Field Ready, a company that provides 3D printing, education, and hardware after earthquake and disaster areas, here it's certainly good enough. 3D printing seals to water pipes or an umbilical cord that is more sanitary than what they're using originally when they don't have anything. So there it's certainly good enough. What about 3D printed solar ink that is only a tenth as efficient as existing solar panels? But maybe it's good enough in an area where there's no energy at all. In this case, you're fighting non-consumption. Or maybe it's good enough in Texas and California where they have too much renewable energy running through the grid. Whereas we heard by Peter this morning, Germany, where they had to pay people that own solar panels to use the grid. This good enough concept is really key to start playing with these technologies when they are in their beta version. In the hearing aid industry, I'm sure you're being aware that this development can go really fast. The good enough took about 500 days to convert an entire industry 100% over to 3D printing. From the first day you use 3D printing to produce the final end part to the last day, 500 days, and nobody who jumped on board 3D printing had survived this shift. So now it's 100% 3D printed in the hearing aid industry in the US. And for this guy, Cody Wilson, the liberator, some of you have seen it, 2013, he made a file of a gun. You could 3D print if you had access to a plastic 3D printer. You only need a bullet and a nail. For the killing blow, that's certainly good enough. Sure, the firearm supplier look at this and say it can only do three shots and then the plastic melts, but it's certainly good enough for that one shot. And who is he? Is he just exerting his rights to speech? He says, I just shared information. But is he an arms dealer? Is he a manufacturer? The regulators don't really know how to deal with him, and I believe they still have his file in caution. And now he's countersuing the authority in Texas for inability to act. And what is a product when it's digital? When does it become a product? When is it only information, and when does it become a product? The Australian government last year took the first stance to define the digital product and said, if you just own a digital file of a gun in your hardware, you, de jure, own a gun. And now they're legislating accordingly. I don't want to think about the technologies they're going to use to be able to hack into your hardware and see if you own it, but they're the first one that I know that have defined the digital product. But is it disruptive? All of the things I showed you now, is it really disruptive? And this is where we tend to say, no, it isn't. It's just incremental innovation. We're trying to copy parts that already exist instead of rethinking them fully, like I wanted with the engine. What we need to do with 3D printing that changes so many design paradigms. What I want to see is this, right? If Ford would have asked his consumers what they wanted before the internal combustion engine, they would have said a faster horse and wheelbarrow. So we want to see this. And then that morphed with another technology, electricity. He was able to optimize and reduce the cost of producing the car by electrification, by electrifying the assembly line. That's how he reduced the cost, and he did so linearly. But with all these digital technologies that follow the same thread, this happens faster and faster. From a strategy point of view, the first step is invest in these technologies. It's going to be painful in the short term, but trust it, because that's the long-term gain you're standing to get. The alternative is exponential decay. Right now, you look at your existing technologies and you like the little gain that you're getting, this incremental gain. But then suddenly, there's a creative crossing. That's what we call the new Kodak moment. Suddenly, the network effects kick in, and everybody changes to the digital photography. When I mention the Kodak moment in my speech, it's often my Kodak moment. We've all heard about Kodak in terms of disruption, quite tired of that example, in fact. But that's where we say, keep asking, so what? Digitalizing the photography was only the beginning for disruption. And the creative crossing wasn't just the digital photography versus the analog photography. It was that it morphed into our smartphones. It morphed with computing, with telephony, and the photography, the camera. That's the creative crossing that Kodak had difficulty seeing. And in fact, it was the App Store, not Instagram, but the App Store that disrupted them. And I could put Nokia down here. I could put so many different companies that were disrupted by the App Store that has dematerialized so many services in our economy. And then, not even here, you should stop. What happens when you combine digital photography with other technologies? So just digitizing the photography has enabled innovation in the way we communicate with each other, the way we find our partner. If you haven't tried this, we can do this later tonight on the boat. It's quite fun, face swap. I can highly recommend it. The bottom line is when you digitize something, you decrease the cost, and innovation blooms. New ways of thinking go in and tap and hack that digital product. And the next step is really the real Kodak moment. When you combine the digital photography with artificial intelligence, you get this. IBM Watson, who's able to forecast in real time on the operation table, comparing CT scans with deep learning algorithms, which is powered by the exponential growth of pictures. Or the modern surveillance society. Wouldn't be possible if it hadn't digitized the photography. And it's not only the public sector that can do it. Facebook, in fact, combined with their drones, have the best data in the world about population density. They know more than the authorities in South Africa exactly where people live in rural South Africa. And the digital photography enables this, the self-driving car. It's fueling a lot of the most powerful algorithms in the self-driving car for the self-driving car to scan its external environment and act accordingly. So when we're looking at disruption, and I'd like you to think about this when you look at 3D printing, it's not only to look at the new technology, but also the new customer need that you can serve, that you haven't been able to serve before. It's not only about replicating the original product, it's about thinking of all the new needs you now can serve. And what is the new market you're creating? Again, ask another so what? And then what is the new value system? And that's a really tricky one. And it's not only about looking at these technologies, there's so many more on the exponential curve. 4D printing, quantum computing, we heard a bit about this morning. There's so many different technologies that you can combine to get an interesting business model around 3D printing. For example, this, Port of Rotterdam probably need to combine their field lab with drones to get parts on board the vessel. Or other types of robotics to reduce human error. Artificial intelligence. This is a company called AI Build that was they were hacking robotics to put on nozzles to 3D print with on multiple axes. They have deep learning algorithm that optimizes the structure and the speed time of the 3D printing process. By that, decreasing the cost significantly by just reducing the time. So this 3D printing process, actually the robotics can see when it has defects in one layer and then automatically adjust for the next layer. And this is the way that they can speed up this process and create these beautiful structures. AI is also going to help us to do real-time life cycle assessment of our 3D printed products to make sure that it is in fact greener, that it is in fact more sustainable, that we can extend the product life cycle by having these new structures that we've never been able to afford before to use in production. We'll see 3D printing merge with new types of materials. This is the first 3D printed part using alien materials. Came out in January this year. NASA, together with natural resources, they took a meteorite that had fallen in Argentina and took powder from that meteorite and 3D printed this part that goes into a space rocket. And the idea here, in terms of the new value system that we're creating, is obviously that when we colonize space, we need to use what's out there instead of shipping the resources from Earth. And what is that going to do when we can use totally new materials or new structures, 3D printing and nanotechnology, another interesting creative crossing that we'll see. This is a nano 3D printed method, a sculpture printed on a hair straw. I cannot even start imagining the new products that we can see when we can control that level of precision. And when I work with the engineers from the analog era, one of my main concerns or main takeaways or recommendations is don't look at the parts that you're having and try to replicate them. This we know, especially you experts in here when you're going to redesign for 3D printing. But think even bigger. Don't design me a chair, design me something I can sit on. We need to go back to the original functions that we need in our human life. And in doing so, it's not about this curve, it's not about disrupting here from below, it's about actually aiming even higher, like Ford did, and push the performance that customers need to a level they didn't even know existed. It's in fact a paradigm shift, moving from the analog to the digital. And we believe it can be actually compared to when we believed the Earth was flat. Shipping, Maersk, was certainly not a big thing back then. And then all of a sudden our mindset changed. There was a paradigm shift and we knew the Earth was round. And all of a sudden there were so many opportunities across the horizon. And that's really what we believe we're standing in front of. I don't believe that all these technologies will take all our jobs like Peter talked about. It will take your current job, but it will create a new job for you. And you have to define that. And one of the most important things to guide you must be the problem, the job to be done. What are the problems out there that you want to solve? And you can go after bigger and bigger problems. Because in the digital space, when the bottom line goes to zero, your top line will change as well. You all of a sudden can afford to ask bigger and bigger questions and go after bigger and bigger problems. Last recommendation about disruption is, again, it's not something you want to avoid, it's something you want to create. You want to create a new technology, a new product for a new customer that creates a new market and even changes the value system. For 3D printing, I think it's really about, there's this design, what should we say, saying that form follows function, right? But it's not that perfect. We've always been constrained to the traditional manufacturing technologies. And in fact, I think that those constraints have actually impacted the functions, the way that we walk about in society, the way I sit on my chair, because it's constrained to those traditional manufacturing technologies. I dare to say that maybe we'll see new functions, totally new functions, because the form allows that. But it requires that we collaborate, and it requires that we have our eyes on the problem. And so a bit last exercise, especially good after lunch, I feel, when like the blood sugar goes to zero, is I'm really keen to see who you are. So I may be the odd one out as a political economist, but I'll be here the entire conference. And I really want to talk about these big problems that we can solve together and how 3D printing plays a role here. So if I can ask the academics to stand up. Now. Yeah? A good share, yeah. And how many engineers, engineering background in terms of academics? Almost all, but not all. Okay, good. Thank you so much for being here. I want to applaud you, although it's not my conference, but I want to applaud you, and thank you for being here as academics. What about the business, the corporates? Can you stand up? And I'd also suggest that everybody else looks at these people, because you know that those are the ones you want to reach out to. Cool. Thank you so much for being here. What about the entrepreneurs? Entrepreneurs, one entrepreneur, two, a bit more, yes. Cool. And then the last box, my favorite box, somebody who didn't feel they fit into any of these boxes. Stand up. Yeah? Oh, you don't really want to stand up, but you're here and everybody knows you're here. Okay, so we're going to talk about you and you'll have some really interesting viewpoints. And I really think that that is needed. I look forward to having a great multidisciplinary dialogue and disruptive one going for the entire conference. Thank you so much for having me.
Thank you, Martha, for a very interesting, invigorating talk.
There is
We've got
5
time
minutes.
for one quick question. This is a burning question from anybody on the floor. we have a sun silence? Yep. And it's raining now. We've got a question in front of
Yes.
How does social disruption fit into your picture? That means the human factor of how humans disrupt progress in technology.
How humans do what, sorry?
Well, humans tend to dislike technology sometimes, and
Yeah.
then they will disrupt it. How does that fit into your scale?
I've learned that there's a lot in communication. Just to overcome that, I know there's a lot of tendency to stand against change. But there's sort of two types of people. One that loves change. The only thing they understand is chaos, because then they can apply structure to it. And then there's some people that have hard skills of their own and see that they're getting disrupted by the new skills needed for them. What we work with is providing like short lists of the new hard skills to actually help those people move over to the new paradigm. And that's really important. So for those that are educated in hard skills from the analog era, they need the new skills. And they need it fast, and they need to know it in bullets. And then the guys that are just excited about anything futuristic and loved Peter's presentation, I think those need a bit of direction. And steering is, okay, great, but what is the problem you want to solve? In terms of my models, everything is social. Everything is social about technology. I should have said when the engineers or my investors told me, when is 3D printing going to do this? When is it going to do that? I should just have said, how much will do you have? And then something about how deep your pocket is. But it's in essence, we that drive these technologies. This Moore's law is not a natural law. It's our ingenuity. And I think subjecting them to that this pace is happening by means of all the new minds that are getting connected to the internet, it's just going to happen regardless. So jump on board now, or be really, really sad later. Yeah.
Thank you. If you all join me in thanking Martha for a very interesting talk. And just before the next talk, a little bit of housekeeping. You hear the thunder out there. There's a BMW in the parking, CV25 GT. It's got the windows open. So you might want to run out there and yeah, get that taken care of. Our next speakers are a double act. Is it still a double act, or we've got a panel discussion with several people. But it gives me great pleasure to welcome all. We'll start with Vilma Swartz, who joined the Longman Group in 2007 and is also non-executive director for Furuya Metals in Japan and director of the Platinum Jewelry Development Association. We also got Dion LeBeer, and Dion, are you going to introduce the other panel members?
No, they will just arrive.
Oh, they just arrive as we go. We have had a lot of talk over the last many years about the shortage of materials for additive manufacturing, both polymers and metals. And I think this talk is very appropriate because I think that we're going to be talking about a new initiative based around 3D printing with platinum. So big developments and big applications in, of course, jewelry, but also power generation, energy, and so on. So I'll hand it over to Vilma, who's going to start it off.